Okay, so again, now, had to start the video over, but I hadn't said much of anything. We've got about, I counted them, looks like there are about 9 threads that we're gonna follow for the next 2 weeks or more. And at that point, you'll have a pretty good picture of a lot of important stuff. And then we get into how to analyze it. And you don't know what I mean by that, so I'm not going to say any more about it, but you'll pick it up. Okay, as we go through this, you'll see more and more what we need to do. Okay, so the first thing again was construction of the grids, the halfway stuff. If you weren't here, it's on the video. People didn't have any trouble with it. But make sure you know it. Make sure you can construct that curve, that shape. Okay, that's the one thing that you need to carry away from that. Now, scaling and everything else, that's also important, but I really just want to see that you can do every detail of constructing that shape. Okay? So review that if need be. As I say, everybody had it. A few people made a little mistake by starting at the lower left-hand corner where you start above that. But other than that, people did a good job with that. Okay, now, one of the other threads is sequences. So we're just going to dive right into that, and we can dispose of what we're going to do with sequences today rather quickly. Okay. I'm going to use S to represent the sequence, and S equals the sequence 3, 8, 13, 18, etc. Now take a minute, write that down, write it down kind of quickly so you don't have to spend a lot of time with it. If you can't see it and want me to read it to you again, just say so. And then tell me what the next 3 numbers ought to be. Okay, so I think everybody got that, 28, 23, 28, 33. Now, I give you a more complicated sequence. It might be a little bit more difficult to figure out what's going on. Right now, we're just going to get one simple sequence, one simple type of sequence that you can okay, this is a new sequence. We call it D of S. So somebody tell me how we got that sequence. Okay, I kind of think everybody knows, but see the little lines here from 3 and 8? What did I do with 3 and 8 in order to get 5? I subtracted first number from the second, right? So I'm just subtracting every number from the one that follows it, right? And those are the differences. That's what the D is. Those are my initials too, without the parentheses. That's just coincidental. I never realized that until I wrote it down. So obviously, the universe agrees with me. Okay. So if I've got the differences, I can always build the next number because now I know if the difference is always 5, then to get the next number, I just add 5 to the last one and I get 23. Then I add 5 and I get 28 and so forth. And I get the numbers that everybody wrote down. Okay. So this is a mathematical operation. Okay, just real quick, let's take another sequence. And do the difference. just kind of quickly write this down and then write out the difference. Write it the way I'm doing. And write it the way I did up here. So you're going to start with a couple of lines like here, and I'll even give you a hint. The first one's 3. What you get between 7 and 12 is 5. Between 12 and 19, it's 7. Between 19 and 28, it's 9. 3, 5, 7, 9. That's an easy sequence to continue, right? But let's say the numbers were a little nastier. Okay. Let's say the differences are in the hundreds or something like that, and you can't immediately see the pattern here. Okay. We can do a second difference, the difference of the difference sequence. Now, formally, I should probably put parentheses around that, but that's optional. Okay. And I get 2, 2, 2. Now, if the numbers are bigger, it might not be obvious that you're getting the same number every time here. But now we can use this to build up the original sequence, right? So we can add 2 to 9 and it'll give me 11. And we can add 2 to 11 and give me 13 and so forth. And then we can add 11 to 28 to get 39. And we can add 39 to 13 to get 52. Now I'm going to tell you there's a formula for this. The formula is n squared plus 3. Now there's a more formal way to write that, but n equal 1, 2, 3, 4, and so forth. In other words, n stands for just your counting numbers. So if n is 1, 1 squared plus 3 is 1 plus 3, which is 4, right? So I've just written them down. 1 squared plus 3, 2 squared plus 3, and so forth. Make sure you understand how those are calculated. And then, since I went past 28, my next number should be, okay, 28 was for n equals 5. 5 squared plus 1 plus 3 is 28. The next number should be 6 squared plus 3, and that comes out 39. And then 7 squared plus 3 equals 52. And we could go on. So if I didn't want to keep writing out the sequence and keep developing it, if I want the 100th member of the sequence, what's it going to be? It's going to be 100 squared plus 3, right? Okay, 10,003. So you don't have to write out all the first 100. You now have a formula. Okay. Well, that's actually a little more than you're going to need to do the homework that's going to be assigned. But that's the right idea. Wasn't recording, but next thread is characteristics of shapes. And one characteristic we've seen already in constructing the exponential function is that shape doubles at a constant interval. Just a every time we move over this far, we double it. That's called our doubling time. We did that last time, so you'll understand that. Okay. Um, scaling windows. Let's say I ask you to sketch the lines x equals 12 and x equals 28. And the line y equals 40 and the line y equals 72. You're going to get a rectangle. So you draw these lines and you extend them a little bit. But then you're going to be asked to fill in the rectangle. In other words, make the boundaries of the rectangle solid so you can really see the rectangle as if you couldn't before, right? Then I think the first thing I ask you to do is just, do the halfway vertical line, do the halfway horizontal line, and label them. Well, okay, so I threw this out, gave people a minute to think about it. We want the equation of this line. It's going to be x equals something. And it's halfway between x equals 12 and x equals 28. What's halfway between two numbers? How do you get a number halfway between two numbers? The quickest way is probably add them and divide by 2. Did you know that? Is that a familiar idea? I hope. I hope you haven't gotten through all your math courses up to now with nobody pointing that out, okay? It's an important idea. It's an average value or a mean value. And I'm pretty sure everybody's seen it. And I think pretty sure that you knew it and just didn't want to say. Okay? Don't be afraid to say. If it's wrong, we're probably going to learn something from that anyway. All right. So halfway is x equals 20. Okay? And halfway from x equals 12 to x equals 20 is x equals 28. X equals 12 plus 28 divided by 2, which is 20. So you can always calculate halfway, even if the numbers are weird. Okay, well, if you do the same thing here, halfway from 40 to 72, that's 112. When you add them, divide by 2, you get 61. No, that can't be right. That's 32. I'd get 56. 112. Ah, look, yep. Okay. Another way to do it is from 40 to 72 is 32. Half of that is 16. Add 16 to 40. If you understand that, it's also valid. And sometimes you do that quicker than you can add and divide by 2. So know that you can do it both ways. Just find the difference, take half the difference and add to the lower one. Or if you take half the difference, you could subtract it from the upper one. You're probably going to want to add rather than subtract. Either way, you're stuck doing some addition. Okay. You know that much, you're going to be able to answer the question comes up in homework. Okay. And the homework is a document. It's a PDF document. It's posted very prominently on the assignments page. To get the assignments page, you go to the Canvas for this course, you read the announcements until you see the link to the assignments page. And while you're at it, you do everything else it tells you to do in the announcements, right? And if you do all that and haven't seen the assignments page, email me and tell me, hey, I read all the announcements and I didn't. I said, well, did you read the announcement about the assignments page? Okay, it's there, but I'll send you the link. Another thing, incidentally, if you email me from your VCCS email, your VHCC email, not from Canvas. Canvas email is a mess. I can't trace anything. Okay? It doesn't give me anything that can be sorted. It doesn't give me anything that I can document easily. Or maybe it doesn't, I just haven't figured it out, but I'm not going to bother. I want to pay attention to one email address, okay? Another thing is, I'm going to have you sometimes send me attachments of scans of your work, okay? Don't send them to me for Canvas because it's a 10-step process to open the bleeping thing, where it's a one-step click to open it in my VCS email, okay? So I might open it one time and tell you never do this again. Of course, if you do, I still be nice about it, but eventually I'm going to tell you, no, not going to open this. Send it to me from your VCCS email. Okay. Okay, anyhow, that's what we mean by scaling. And then there's equations. You got to be able to solve equations in this course. There's going to be a lot of equations, but we're not going to see a whole lot of them. We're just going to kind of build up your equation solving skills, one type of equation at a time for a couple of weeks here, okay? One type of equation per class. But I'm going to tell you two of them today because they're easy. Okay, let's see. Let's see if you can solve this equation. And let's see you solve this equation using valid algebra steps, not just looking at it and trying different numbers and seeing what you get. Show me the steps of solving this equation because you're going to want to do everything in very meticulous, well-documented steps in order to not spend the course stumbling over your equations, okay? I mean, you might eventually run into an equation you can't solve, but make sure you've got the procedures down. So just want to see what you got. Some people wanted to start by dividing by 5, and that's a terrible idea, but it's not a bad idea. Okay. The reason it's terrible is, first place, you'd be prone to doing it incorrectly because you can't just divide 5x by 5. If you're going to divide by 5, you got to divide the whole side by 5, right? And some people have the whole side divided by 5 equals this whole side divided by 5, which is a valid step. There's nothing wrong with that, except that it makes the problem a little bit harder to do. Okay, you would end up with something though. It could be a valid step. It's a little more confusing. What you want to do is you want to do additions and subtractions before you do divisions and multiplications. That's your order of operations for simplifying expressions, but it's also very important when you're solving an equation. So most of what I saw looked like this, okay? Meaning you're subtracting 4 from both sides, right? Nobody did it quite the way I want to see it, though. What's this mean? That's nothing. -4, -4. What? It's the equation -4 equals -4. And I want to see that equal sign because you need to be thinking about adding equations right from the very beginning because it's a stumbling block for people. And you need to realize that you're adding an equation to an equation. You're adding a true equation to an equation because -4 does equal -4. Okay? So we add a true equation to this equation and we get an equation that's going to be really easy to solve. Okay, so 4 minus 4 is 0. And that just leaves us our 5x. We don't have to write the 0 because we're adding it. And of course, 39 minus 4 is 35. And now I don't just put over 5 here. I write the steps. 5x over 5 equals 35 over 5. Okay. And then the 5 here divides the 5 here because the 5 is a factor of the numerator. It is the denominator. And you get x equals 7. Okay. And then you check. I like to write it like this. 5 times 7 plus 4 equals 39. You plug 7 into the original equation and see if it's true. And you put a question mark over that equal sign because you're asking if it's true. Because you're eventually going to make a mistake. It's a really complicated equation. It might be a high probability you're going to make a mistake and have to fix it. Okay? If there's a problem when you have 100 opportunities to make a mistake, you're not likely to get through it in the first try. And you're going to have to know that there's an error and how to fix it, check it. Also, you always check your solutions because that gives you immediate feedback whether you're doing it right or not. Okay? You don't just say, oh, okay, I think that's right. You write it down. It's wrong. You didn't learn anything. Okay? You made a mistake. You didn't find out. You didn't realize that it was a mistake. Okay? So we have 5 times 7, which is 35, plus 4. Of course, the arithmetic is simple. You can do that. And that gives you 39 equals 39. And then you write down yes, answering the question of whether this is equal to this. Okay? Or put a check mark there or something. Indicate that you've checked it and you understand that the check works. Simple enough? Okay, you're going to have an equation like that. I think you're going to be able to handle it. Now we get a little more complicated as we go on. There's another kind of equation I'm going to go ahead and introduce. The equation reads quantity x plus 4 multiplied by the quantity x minus 6 equals 0. Going to give you a minute or two, see if you can come up with a solution by hook, by crook, or whatever. I'm thinking of two numbers, not related to this equation. I'm thinking of two numbers. And when I multiply them, I get 0. What can you tell me about one or more of those numbers? Okay, I asked a question. I'm thinking of two numbers, they haven't multiplied out to 0. What can you tell me about at least one of the numbers? And I got the answer. Okay. When you multiply by 0, you get 0. So one of the numbers got to be 0. Because if you don't multiply by 0, if you multiply two numbers that aren't 0, you're not getting 0. That's the other part of it. You got to understand that, but I think everybody understands that. Okay, so x plus 4 times x minus 6 equals 0 breaks into two equations. X plus 4 equals 0, or x minus 6 equals 0. And this is the way I write it out. Now that's written kind of small if you're sitting in the back. I'll just read it. I just take the x plus 4, say that equals 0. I put a big old fat OR for or. X minus 6 equals 0, which is the way I want to see this done. Because there's logic involved. And the or is a logical connective, okay? And then if x plus 4 equals 0, well, you can subtract 4 equals 4. You can do negative 4 equals negative 4. And you get x equals negative 4. Or you do plus 6 equals plus 6. I'm writing that real small because it's clear that X has to equal 6. Okay? Does that make sense? So when you have a bunch of things multiplied together and they give you 0, you just set each one equal to 0. You just break it into whatever number of equations you have to and solve the equations. Now, if the equation's something that's hard to solve, you might not be able to solve it. But in this case, the equation's really easy to solve. And if I gave you one like this, and we're not going to talk about it, but if it's 3x minus 7 multiplied by 5x plus 4 equals 0. Well, you just break this into two equations. 3x minus 7 equals 0. 5x plus 4 equals 0. There's a big 4 in there, and solve them. And everybody can solve those equations. You showed me that just a few minutes ago. Okay? Okay with this? You want to remember that throughout the course. There are other places where an equation splits into two equations. You'll see those pretty soon. And as much as I emphasize that this is what you got to do, we get to test and nobody does it. Okay, even though it's really easy and actually very easy to understand. Tells me people aren't preparing for tests properly, not reviewing. Because it's not that they can't understand it. We'll cross that bridge when we come to the whole idea of what it takes to review for a test. Okay, moving along. There are a couple of these that I'm just not even going to talk about because I think you already know how to do them from what I've seen. But if it turns out there's a problem with some of them, you know, we'll address it. Okay. What is 10 divided by 2 and why? Okay, if what it is, everybody knows it's 5, right? Can you explain to me why it's 5? Okay, so I got some good explanations. They're all, nobody said anything that wasn't true and relevant, okay? But I think the most direct reason 10 divided by 2 is 5 is I'm holding up my hand. It's my left hand. And I'm going to use my right index finger in my right hand, and I'm going to count 2, 4, 6, 8, 10. And I counted every one of my 5 fingers. It means that there are 5 2s in 10. Okay? So that's a sequence, incidentally, with a common difference of 2, right? And there are 5 of them. So it's there are 5 2s in 10. Okay? Can you count to 1 by 0.1? Can you write down the numbers that you would count? Like 2, 4, 6, 8, 10. Can you count? You write down the numbers that you would count by to count to 1 by 0.1. Jot them down on your paper. Let me just see if everybody's thinking along the same lines. Okay, now most of you wrote 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, right? And one person did it a little differently, but would also then be able to count the 0.1s and get the right answer and equally valid, okay? But I'm going to say then, okay, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Written kind of sloppily here. You probably can't read it from where you are, but you know what I wrote. How long did that take me? 10 seconds? Maybe a little more. Okay, but not more than 15. Okay. Now, what if I kept counting? I mean, that's a nice sequence there. You know how the sequence continues. So write down the next 3 numbers. Come after that. Okay, everybody did that correctly. You got there it is. I've gone all the way to 100. I just put 3 dots there for everything in between. And how many numbers would I have to put in if I wrote them all out? I'd have to put a bunch of numbers in there, wouldn't I? Okay. How many think I could do it with 100 numbers? How many people think it would take more? How many people think it would take less? Okay. Well, let's see what people think. Okay, now the big point here is if you're wanting to count to 100 by 0.1s, it's going to take you a little while because it took you 10, 15 seconds to get here. Okay. It's going to take you another 10, 15 seconds to get up to 2. You've got 50 times that long to go. If it's taking you 15 seconds to write down 10 of them, okay, then it's going to take you 1,500 seconds, okay, by 25 minutes to write them all down. Now, if you're doing them one at a time, I think my numbers are right there, I don't know. But your list is going to be pretty long. If you write small, you can probably get it onto 1 page. It's probably going to take you, and then somebody said 16 minutes and 40 seconds, which is 1,000 seconds. So you write 1 number per second. Or if you can count 1 number per second, you can say them in that time. So it's 1,000 because there are 1,000.1s in 100. Okay, which is easy enough. There are 10.1s in 1. If you multiply 10 by 100, you get 1,000, and you can do that too. But I want you to think in terms of lists and stuff because we're eventually going to be talking about how the limit of a process approaches infinity. Like if I ask you, instead of dividing by 0.1, I ask you to divide by 0.00001. Could you do that in a lifetime? Could you do it in a week? How long would it take you? You can figure it out, but just the question. I want you to understand that dividing by smaller and smaller numbers gives you huger and huger results without any limit. Does that make sense? There are problems that ask you to think about that and spread out over 2 or 3 of the assignments, okay? Easy ones on the first assignment and then a little harder, but if you understand this, you can answer them all right now. But I want you to think them through, and I want them written out in your notebook with some kind of reasoning so that when you need that insight, you will have written it out and processed it properly. So it'll be there even if you haven't thought of it for a year or two. Okay? Lock in the idea. I just filled this graduated cylinder from the 20 milliliter to the 80 milliliter mark. And everybody counted the number of seconds, right? So people are going to get different counts. But we want to figure out on the average how fast was water rising in that tube. Does that make sense? So what would you do to figure out how fast on the average water was rising? Try to pause. Okay, now about half the class got this pretty quickly. And the other half, all the words are confusing and everything, but the idea is very simple. So I go to the simpler case that's probably more familiar. Let's say you make $300 in 5 hours. Most people are willing to work at that rate, right? Okay. $300 in 5 hours. What's the calculation that you immediately make? Well, I'm making $60 an hour. That's pretty good. Okay. It's $60 over hours. And that's the way you would write out the calculation. Calculation here. Well, it depends on how much time you think it took. Everybody's got a different time. And about half the people wrote it down quickly. A couple other people got it after a little bit of a delay. We call this the average rate at which your wealth is changing with respect to time. That's what a pay rate is. Okay. This is the average rate at which water level is changing with respect to time. That really wasn't water level because water level is not measured in milliliters. Okay. The amount of water is measured in milliliters. Okay. So, but I said water level because that's the way I phrased it first. I'll say water amount changing with respect to time. And it's, okay. Average rate is a change in the amount over the change in time. The change in the amount was 60 milliliters, right? We're doing time like we're out of time. Let me real quickly. Amount change from 20 milliliters, 60 milliliters to 80 milliliters, sorry. So the change in amount is 60 milliliters. If the time is 10 seconds, then your average rate equals 60 milliliters over 10 seconds, which is 6 milliliters per second on a graph. You could have X equals 20 milliliters. X equals 80 milliliters. P equals 0 here. T equals 10 here. So you have the point 20 milliliters when the time is 0. 80 milliliters when the time is 10. Here's your 60 milliliters. Here's your 10 seconds. And I did it backwards because I'm in a hurry. But anyhow, you can write this in terms of lines on a graph, okay? You just calculate how far you got to go over, how far you got to go up or down. Make sense? Okay. You should be in good shape to do the homework that is due Tuesday. And you should have seen a lot of what you need to do the homework that'll be due Thursday, and it's still going to be due Thursday. If necessary, I'll do another video and post it so that you have access to that on Thursday. It'll be at the assignments page. If you can't find the assignments page, read the announcements again. If you still can't find it, admit it and email me and I'll send you the link. Okay? And also get into the open math and at least do that introduction. But that's the only thing they'll be due. If you've already done the functions thing, that's fine. Because we will be doing it, but probably not for a couple of weeks.